Tattoos have often been presented in popular media as either marks of the dangerous and deviant or trendy youth fads. But while tattoo styles come and go and their meaning has differed greatly across cultures, the practice is as old as civilization itself. Decorative skin markings have been discovered in human remains all over the world, with the oldest found on a Peruvian mummy dating back to 6000 BCE. But have you ever wondered how tattooing really works? You may know that we shed our skin, losing about 30 to 40,000 skin cells per hour. That's about 1,000 per day. So, how come the tattoo doesn't gradually flake off along with them? The simple answer is that tattooing involves getting pigment deeper into the skin than the outermost layer that gets shed. Throughout history, different cultures have used various methods to accomplish this, but the first modern tattooing machine was modeled after Thomas Edison's engraving machine and ran on electricity. Tattooing machines used today insert tiny needles loaded with dye into the skin at a frequency of 50 to 3,000 times per minute. The needles punch through the epidermis, allowing ink to seep deep into the dermis, which is composed of collagen fibers, nerves, glands, blood vessels, and more. Every time a needle penetrates, it causes a wound that alerts the body to begin the inflammatory process, calling immune system cells to the wound site to begin repairing the skin. And it is this very process that makes tattoos permanent. Well, according to the American Psychiatric Association, addiction is a complex condition of the brain where a person has compulsive substance use despite there being harmful consequences. People with addiction tend to have an intense focus on what they're addicted to the point where it takes over their life. What makes it so hard to break an addiction is that it can change the way your brain is wired, giving you harsh cravings that make it difficult to stop. Studies of brain imaging have even shown changes in areas of the brain that relate to judgment, decision making, learning, memory, and behavior control. So, is this what's happening with Facebook and social media? It's hard to say for sure. That being said, we are starting to give more credit to an addiction that might be pretty similar: video games. That's because the American Psychiatric Association includes internet gaming disorders as disorders that require further research, but that can result in clinically significant impairment or distress. The World Health Organization has also added gaming disorders to their International Classification of Diseases, which is used by medical practitioners around the world to diagnose conditions. Now, online video games are obviously not the same as a site like Facebook, yet they do have similar social aspects. It's possible that in the future we'll see health organizations also classifying social media as a type of addiction or disorder. Still, sites like Facebook do have quite a few qualities that make you want to come back to them. Through constant feeds that go on forever and giving you push notifications on your phone, social media sites try their best to keep you on their app or website, and if you leave, they want you to come back as quickly as possible. Google and Facebook further their reach by also being commonly used to sign into other sites. Social media sites also seem to have a significant impact on how you feel, furthering your connection to them. We've all heard the phrase, laughter is the best medicine. But why do we laugh in the first place? It seems that laughing might be a little more hardwired into us than you might think. Infants laugh very early in life, usually learning how to laugh before they can speak. Not only that, but people that are born blind and deaf can still exhibit laughter. One study found that the laughter produced from deaf participants was fundamentally similar to that produced by normally hearing individuals, backing up the idea that laughter is grounded in human biology. It's also been theorized that laughter predates human speech by potentially millions of years, being a simpler form of communication. Laughter is thought to have likely helped earlier people negotiate group dynamics and establish hierarchy. I can't even imagine trying to explain that I'm a little goofball using only laughter. So, if laughter actually is instinctually part of humans, then why do people laugh? It seems like laughter is more of a way for people to better handle stress and make situations feel less threatening than laughter only being about things that we find to be funny. In practice, with a study of 1,200 people that laughed spontaneously in their natural environments, only about 10 to 20% of the laughing episodes followed anything the researchers found to be joke like. Finding something funny still seems to play a part in why we laugh some of the time. But laughing to make yourself feel better about your next difficult exam might be just as probable as cracking up over that joke you just heard. But what exactly happens to your body when you're in a coma? First, we have to be clear that comas are very different from sleep. Despite the fact that the origin of the word comes from the Greek for coma, or deep sleep, comas are not sleep, however, and are instead various forms of unconsciousness that render a person unable to respond to any external stimuli. You can play the loudest, heaviest death metal in the world right next to someone who's comatose, and you won't succeed in doing anything except really annoying the neighbors. Likewise, you can even physically hurt people in a coma, and they will remain completely oblivious and unresponsive. In times not too distant past, this was sometimes used as treating, with doctors trying to shock their victims back into consciousness. Everything was tried from exposing parts of the body to open flames, to severely dropping the body's temperature with ice, to even bloodletting from the head directly. One treatment even included wholly emptying the stomach, we guess, because the doctors thought that if a patient got hungry enough, the body would force them to wake up. Or maybe they really were just throwing everything, including the kitchen sink, at the problem, which we're sure was also tried. Comas can occur as a result of serious trauma or as a deliberate medical treatment by doctors. They are typically brought on by traumatic head injury, and it's believed that it's the brain's way of shutting down so it can focus on repairing itself. They can also, however, be brought on by a stroke, a brain tumor, drug or alcohol abuse, or an illness such as diabetes or an infection. Most of the time, a coma only lasts a few weeks, though. But past this period, the patient can enter a persistent vegetative state that severely lessens their chances of ever coming back out of one. Why can't we transplant brains? First of all, we should look at what the brain actually does. This thing inside our skulls that weighs on average about 3.3 pounds is larger in humans than any other vertebrae when compared to body weight. That's why we are so brainy. The busy brain is our command center for our nervous system, which takes in data from our body and gives directions to our muscles. In fact, it does so much work, it requires about 20% of our energy to run it. When we are brain dead, we no longer have any neurological activity. With the help of machines, we can be kept alive for a short time, but within a week, the body will not be able to function. While we may still be alive in some sense for that week, we are technically dead when the brain is dead. Some good news is that during the time we are kept alive, some of our other organs can be donated. But why can't we accept someone else's brain? When we transplant something such as a heart, surgeons use a mechanical pump to keep blood flooding through the body while the new heart is being put in. The new heart is then connected to the major blood vessels, and this might take several hours. You'll stay in the hospital for 1 to 2 weeks, and if your body doesn't reject its new heart, it's said 87 out of 100 people make it through the year, and 60 out of 100 get through another decade. So, wouldn't it just be possible to open the skull and connect a new brain where the removed brain was connected? This question was asked to a professor of neurosurgery at Yale in 2013. He actually did say that one day this operation might be successful, but right now we are not even close. The reason is because it's just too darn difficult to connect nerve fibers from the new brain to the native spinal cord. This, he said, is why spinal cord injuries can be so devastating. If we could transplant brains, we would likely not have so many people that are disabled due to spinal injuries. While a written word might have multiple definitions, we can usually determine its intended meaning through context. In speech, however, a word can take on additional layers of meaning. Tone of voice, the relationship between speakers, and expectations of where a conversation will go can imbue even words that seem like filler with vital information. This is where and come in, or e and m, to toi and o, eto and ano. Linguists call these filled pauses, which are a kind of hesitation phenomenon. And these seemingly insignificant interruptions are actually quite meaningful in spoken communication. For example, while a silent pause might be interpreted as a sign for others to start speaking, a filled pause can signal that you're not finished yet. Hesitation phenomena can buy time for your speech to catch up with your thoughts or to fish out the right word for a situation. And they don't just benefit the speaker. A filled pause lets your listeners know an important word is on the way. Linguists have even found that people are more likely to remember a word if it comes after a hesitation. Hesitation phenomena aren't the only parts of speech that take on new meaning during dialogue. Words and phrases such as like, well, or you know function as discourse markers, ignoring their literal meaning to convey something about the sentence in which they appear. Carbon dioxide, or CO2, is the main greenhouse gas in climate change. So, how does CO2 get into our atmosphere? Well, carbon is part of a cycle. It starts with the sun, which heats the Earth's surface with more energy in 1 hour than the whole world uses in a year. Plants, which are kind of like biological chefs, take that sunlight and then suck in some CO2 from the air, mix them together, and bam! They create a stored form of energy in the form of carbohydrates such as glucose and sucrose. The process is called photosynthesis. When animals like us eat those plants, our stomachs convert that food back into energy for our own growth. Greenhouse gases are a byproduct of this process and are released through waste. If those plants die, they decompose and tiny microorganisms break down those carbohydrates and again release greenhouse gases as a byproduct. As you see, energy originates from the sun. It is then transferred as it moves through the food chain. But sometimes carbon-based organisms like plants or animals get stuck in the earth. When this happens, they're compressed under tons of pressure and turned into carbon-based fossil fuels like oil, coal, or natural gas. Take a look outside a window. What is the season where you are? How do you know? Most likely, you looked at a tree or plant and noticed details about its leaves and assessed the qualities of sunlight streaming outside. Observing the timing of biological events in relation to changes in season and climate is called phenology. When you notice the daffodil buds are poking through the snow and think spring is on its way, you're using phenology. When you see leaves turn from green to red and watch migrating birds fly past and realize that summer is over, autumn is here, you're using phenology. Literally meaning the science of appearance. Phenology comes from the Greek words pheno, to show or appear, and logos, to study. Humans have relied on phenology since the time of hunters and gatherers. We've watched changes in seasons to know when to plant and harvest food and when to track migrating animals. Scientists observe and document seasonal changes in nature and look for patterns in the timing of seasonal events. Timing of these natural signs has remained consistent until recently. Increasing global temperature is causing rhythms of nature to shift. Bud burst, the day when a tree or plant's leaf or flower buds open, occurs earlier in the year for some species. For every 1 degree Celsius rise in temperature, bud burst happens 5 days earlier than usual. Differences in timing affect not only plants, but the insects and birds that depend on the plants for food. It's rare to find an adult who actively still wonders what their parents think. But that isn't to say that we aren't wondering about our value in more general terms. It's just that we may, without noticing, have taken the question somewhere else, and very often to particularly harsh modern figures of authority, media and social media. To this pitiless arena, the self doubting person now directs all their fears of unworthiness and panicked desire for reassurance. To a system set up to reward sadism and malice, they constantly raise their phones and implicitly ask, do I deserve to exist? Am I okay? Am I beautiful or respectable enough? And because social media is built on the troubles of the individual soul, the verdict is never a reliable yes. One is never done with cycles of fear and reassurance seeking. Every time their spirits sink, which is often, the self doubting sufferer picks up their phone and begs to know whether they have permission to go on. If this might be us, we should grow curious about and jealous of people who are free. They are so because someone long ago settled the question of what they were worth, and the answer has seemed solid ever since. Social media is a roar in the next valley, not a mob in their own mind. Learning from these calm souls won't just involve deleting a few apps. We will have to go further upstream, back to the baby self, whose alarmed inquiries we must quiet once and for all with ample doses of soothing and till now absent kindness. Okay, so this is the big benefit of a universal philosophy. It says it applies to everybody. Well, it looks like there aren't, 205 or 206 countries in the world, and you've got something that applies to everybody. That's a bit strange, isn't it? No, says liberal theory. There are the same value structures that apply to all of us. You couldn't have the United Nations without it. It couldn't tell you that the Universal Declaration of Human Rights without this idea of values that apply to all of us just because we are humans. Now, the idea is to test that as well. Why is sport universal? Why does everybody play football? It's because the values are specified at a very thin level at the top. There are these rules, and we all have to abide by just these rules. But there are lots of things about football that aren't rules specified. So Brazilian football is different from Italian football, British football, German football, and Spanish football. It's culturally specific, but acknowledges that there are these universal general rules to apply to everybody.
Thank you for watching this video. Will help you a lot, and subscribe our channel Vital PTE Academy to see more education related videos of PTE Academy. I will meet you in next video.